Hello, YouTubers! Welcome back to another episode. I'm your host, MrMultiMediator, and today we are going to develop a code that tracks an investment throughout its lifetime based on the information you provide the program about the investment, the principal, the interest rate, the number of years that the investment accumulates for, and finally a continuous investment. So basically, the code is going to take an input file like this. The input file looks something like this. So let's say your principal is $5,000 and your interest compounds at an average of 5% per year. The loan is, or sorry, not the loan. You let this investment mature for 30 years, and continuous investment is just basically how much you put in this investment per month. So let's say you also add $100 per month. And finally, this is just how often it compounds. This doesn't make much of a difference, but if it compounds monthly, then it accumulates monthly. It can also be daily. It can be annually. This number doesn't make very much of a difference, but I can show you the differences. But in any case, each line of this input file is a different investment. So you can compare. That's the great thing about this program, and it will run through the input file and spit out the final value of the investment after the end of the period. In this case, after the end of the 30 years. So yeah, let's say you're interested in that, but you also want to know, well, what if I didn't get 5%? What if I got lucky and I got 8%? And you still want to know 30 years, and you have a continuous investment of 100, and it compounds monthly. And then you say, well, okay, and what if I'm unlucky and it only compounds by 3% per year? And then you say, okay, and what if I'm at 5% again, but I don't add any money to it? So I'm not adding any money into it, and I'm just letting it mature over 30 years. Then what's the result going to be? You can do that. You see what I mean? There's a whole lot you can ask this program. You can ask it, what if I started with $10,000 and it compounded at 5% per year for 30 years without me putting any money into it, and it's compounding monthly. So yeah, there's a whole bunch of different. You can change the period. You can say, what if I only ran this for 20 years, for example. And then finally, you can change the compounding to annual or daily if you wanted, but it's not going to make that much of a difference. But I kind of want you to all see what that does. Daily. Okay, so this is like the form that the input file takes. So yeah, and now let's get into writing the code that's going to parse this input file. And remember, at the end of the video, we're going to have a code that outputs the final value of each of these investments. And you can put them all side by side, which is really nice, because then you can compare what different sorts of investments would give you. Like you say, then you can estimate. You can say, okay, well, I have this much principal. I'm guessing I'm going to have this much interest. I'm going to leave it for this many years. I'm going to put in this much every month. And then you can see what the final value of your investment's going to be. And then you'll say, oh, I kind of want more than that. So maybe I'll put in a little more. I'll put in a little more every month. And then you can see exactly how that would change. So like, let's say you're assuming 3% per year, and you want to see more aggressive investment, what that does. 200, 300. So you can really get to see trends here of how certain variables affect the final value of your investment after 30 years. And I think this is a valuable program to use because I've kind of always wondered this sort of thing, and I've always wanted to be able to do this really quickly, quick and dirty. Just instead of having to do it all in my head, I could have a bunch of different scenarios right in front of me that I could compare. Also, maybe you have a bunch of different investments, and that's another thing this program could be used for. You could have each of these is a different investment of yours that has a different amount of principal and interest and number of years, and you could compare the final value of all of your investments to see what like the what your net worth is going to be like at the end of your lifetime, for example. So that's the two, what I perceive to be the two benefits of a script like this is, one, you get to compare a bunch of different scenarios to see which is best for you based on how much you can contribute and how much you want at the end of the lifetime of the investment. And you can add up a whole bunch of different types of investment all at once. So let's get into it. Let's get into the code. So I am here in my working directory in my Ubuntu Linux subsystem for Windows, and I'm in my working directory, and in this directory I have the input file, which I'm just calling data.txt, and the Python script that we are going to develop. So it's a really short script. So we're going to just import sys. This is our main program. So it's going to read the input file. I'm actually copying. I wrote this script already, and I'm just copying and pasting everything. Or not. I'm not copying. I'm literally typing this by reading it and retyping it. So it's like we already talked about. Each line contains 5 variables: principal, interest rate, number of years, continuous investment, continuous monthly investment, and a compounding rate. Run through the compound interest calculator, which will print the result to the screen. So I can zoom out a little more. There we go. So the first thing I create is a dictionary called compdict, and it's a dictionary. You'll see what this is for later. Let me just write this out. Monthly 12. Let me just copy and paste it. So this is the number of this thing in a year. So there are 12 months in a year. There's 1 year in a year. There are 2 half years in a year. There are 52 weeks in a year, and there are 365 days in a year. And you'll see what this is for later. So zoom out even more, actually. Okay, I guess I can't. Okay, so I'm just going to say f equals open. Whoops. So this is a command line argument from the user. This is just to skip the first line of the input file. Open input file. Print. So what it's actually going to print after it does everything is it's going to, in this order, it's going to print the principal, the interest rate, the years, the compound rate, the continuous investment, and the final amount of the investment. So now it's just running through the input file for line in F, and it's going to call this function that I'm going to write called running int. I don't know why I called it that. I think it's running interest. I think that's what it stands for, which kind of doesn't make sense, but. So it literally takes an order. So this function called running int is going to have this format. This function will be defined above the main code up here. So it takes principal, interest, years, continuous investment, and compounding. So I'm just going to copy and paste. Yeah, so it's taking these parameters for this function from the input file. That's all it's doing. And the input file is here again. So, and then after that, that's it. And then it closes the file. So all we have to do is define this function. CINV is the continuous investment amount, the amount added to the account each month. Okay, so amount is the amount in the account, and this is the number that's going to keep on getting updated every year. So amount equals principal. Counter equals 0. While counter is less than years times compound. Oh, right. And compound, so I told you I was going to explain this. Compound is compdict line dot split minus 1. So line dot split minus 1 is the very last item in the line. So here it's monthly. So compdict monthly. And compdict monthly is 12 here. So basically, this variable compound is going to be called 12. So while counter is less than years times 12. So basically, it's looping over the number of compounding periods. So if it's a 10-year loan, but it compounds monthly, it's going to compound 120 times. So yeah, so that's what this is doing. So it's every compounding period, it's going to add the corresponding amount to the account. So I just have amount equals amount plus amount times interest times 0.01 because it's in percent and I have to convert it to fraction. Divided by compound plus continuous investment times 12 over compound. Counter plus equals 1. Right. So this is the compounding right here, the interest. So whatever the interest times 0.01 is the fraction that gets compounded. So it's the amount times this fraction divided by, for example, 12 if it's compounding monthly. If it's compounding annually, you're dividing it by 1. But then you're also adding this continuous investment, which is monthly, times 12 over the compounding. So this is to account for the fact that we're not looping over years, we're looping over compound periods. So for example, if we're doing monthly, it would be 12 over 12. So this would just be CINV. But if we're doing annually, you'd want to multiply it by 12 because a year has gone by. So it would be CINV times 12 over 1. I hope that makes sense. I don't know if I'm explaining it well, but yeah. So this second addition to the amount is the continuous investment, and the first addition is the compounding interest. You could argue that this wasn't done properly because maybe the continuous investment should also be subject to the compound interest. But my argument, I guess I'm arguing here that this is being added and then it'll be compounded in the next cycle. That's kind of a little nuance that one might want to change. But in any case, this is how I did it. You could make it so that this gets compounded right away, but in any case, I didn't do that. So you're incrementing the amount by the compound interest and also by the continuous investment every compounding cycle. And then at the end, it's just going to print the principal, the interest rate, the years, the compounding rate, I guess, the continuous investment, and the final amount. And that's it, really. That's it for the code. So we'll go ahead and run it now. So here's my input file. So I'm just going to go ahead and run Python interest.py with the input file data.txt. And there you have it. So I invested $5,000 with a 5% interest rate over 30 years, compounding monthly, and that adding $100 every month, and then I ended with $105,564. And I say, oh, I want a little more than that. What if I was luckier and I got 8% per year? All other variables the same. I end up with $203,000. So that's significantly better. What if I was less lucky and I got 3% per year? $70,000. What if I got 3% but I put in $200 every month? $128,000. That's a little bit better. $300 per month? $187,000. What is this one? Oh, what if I got 5% per year, like this one up here, but I didn't put any money in ever? You still end up with $22,000. That's pretty nice. You put in $5,000, you just let it sit for 30 years, and then you have $22,000 at the end of the day. 10,000. Oh, and then I say, well, yeah, I do like the idea of not having to continuously put money into this. What if I start with 10,000 instead of 5,000, and I wait 30 years? Then I end up with almost $45,000. That's pretty good too. I mean, obviously, it's double this number. That's exactly what it is. It's double this number. And then I say, well, what if I only look at 20 years, $27,000? Not as attractive. And then finally, you can see that the compound rate doesn't affect the final number very much. It's fractions, but it affects it slightly. So there we go. There you have it. And now, like I said before, if these all represented different investments that you have in your portfolio, and you could put them all side by side, and then you could add them all up, and then you could calculate your final net worth. So that would be valuable. Yeah. And other things you could do is, well, I haven't rigged the code to do this, but you could slowly change one variable and plot the final amount in your account as a function of that final variable, just so you can get an idea of how that trends how the final account value trends with that variable. So you could say, well, how exactly does my final account value trend with interest rate? For example, they say that I think it was what is it? 10% growth corresponds to doubling every 7 years. So that's a trend. But you could tease out trends like that by seeing how this number trends with a single variable as a function of a single variable. Actually, that could be an interesting thing that could be added to this code. Where, like, for example, instead of just printing, it's it's storing it, and then it plots it at the end. Maybe let's do that. Let's do that real quick. So for example, let's say I wanted to see how the final amount trends with interest rate, all other things being equal. So let's try that. So okay. So these are all the same except the interest rate. I'll save this. And we want to see how this trends. So what we're going to do here is we're going to return we are going to return the interest rate and the amount. Investment info equals this. So now what I'm going to do is I'm going to have a variable called amount out here, but it's going to be an array. These are local variables, so I can use this name out here. And I'm going to have interest also as an array. And every time it runs through the file, I'm going to have interest dot append inv info 0. Oops. Info. And then amount dot append inv info 1. And then at the very end of the program, I'm going to do plt dot plot. So I imported matplotlib here, as you can see. I want the y-axis to be the interest, and the x-axis to be the amount. And I want to plot them as circles. So, and I want to show that. So now when I run this, it should plot the final account value as a function of the interest rate. And I think that's pretty cool. So let's go ahead and do that. Okay, so I'm doing this on my Windows command prompt because for some reason the GUI, the X11 isn't working for some reason, so I can't show plots from Ubuntu. So here we go. So I'm gonna run this. So yeah, let's go back to the data. If you remember, my principal is $5,000. I run this investment for 30 years, putting in $100 every month with varying interest rates. And here's my plot of final account value in dollars as a function of interest rate. And it seems basically exponential. I mean, you can see with the 3% rate, it's pretty low, and you start to get really big returns once the interest rate gets higher. So yeah, it's almost linear looking in the lower region, and then it starts to take off. So you really want to get a high rate of return if you can. But obviously to continuously get 12% on your investment per year would be pretty lucky. Most things, like, I can't think of that many things that grow that fast for that long. or that grow that much for that long of a time. I mean, I guess the economy of China did that for the past, for a 30-year period, but that's super rare. I mean, maybe Japan did that too and maybe even the U.S. did that at some point. But like, things don't grow like that anymore. You're more likely to get like 7 or 8% if you're lucky, maybe 10, more likely 6, 5. And if it's a more conservative investment, you're more likely to get like 4 or 3 or even 2, honestly. So, but still, I mean, considering where you started, $5,000, this isn't bad. Yeah. Anyway, I think that's it for this video. So I'll talk to you all later. Have a good day. Bye.